how-to videos, work in energy example 2A, work with an angle. Whoa. Bob is pulling on a sled, and we have the sled here. And we got some forces acting on it. We've got a gravitational force downward. We've got some type of normal force acting upwards. I don't really know how big it is. Although I do technically know it's going to be smaller than this gravitational force. Why? Well, because I've got this additional force from Bob at that angle. And I know the total up has to equal the total down in terms of those forces. But that doesn't really matter. So the sled and the sister together have a gravitational force of 215 newtons. And I know that this tension force is going to be, let's see, that's going to be 62 newtons. And we're being pulled a certain distance of 12 meters, okay? And it looks like we've got an angle of 55 degrees. So it's not quite drawn to scale, but that's pretty good still anyhow. 55 degrees. Okay, so if we're looking for a moment based upon what we saw in the last example problem, we should always check first to see what direction of the force and the distance is. In case they're perpendicular, we know it's 0 immediately. Well, I know that force is kind of going like this. And let's see, distance, let me just use a different color to emphasize. It's a different thing. Distance is like that. So that means this angle here is not 90, but it's not 0 either. So we'll have to do with the cosine theta. Okay, so work is force times distance times cosine theta. Well, I know what the force is that I'm pulling with. That's 62 newtons. You say, oh, I could use the gravitational force, right? Why don't I use that? Well, that's going downwards, and that's going to be perpendicular to the direction of motion. Gravity is not actually doing any work here because of the perpendicular. So the force, which was 62 newtons, times the distance, which is 12 meters, times cosine of the 55 degrees. Okay, tap into our calculator. We have 62 times 12, and that would be 744 joules. And then times the cosine of 55. Cosine of 55 is 0.574. And this is work. And then work equals 426.7 joules, or we can just round off reasonably enough to 427 joules.